The seemingly simple zipper, now a universal fixture, once failed over 100,000 times before widespread adoption. Early designs routinely jammed, broke, or refused to fasten, causing immense frustration and public ridicule. Imagine a world where your clothing constantly malfunctioned, leaving you exposed at the most inconvenient moments. This persistent problem nearly doomed the revolutionary fastener entirely. Despite its undeniable potential for convenience, the concept of a slide fastener emerged in the late 19th century, promising unprecedented garment closure ease. Its inventor, Whitcomb Judson, envisioned a hook-and-eye shoe fastener, a truly novel idea for its time. People were tired of tedious buttoning and lacing, eagerly awaiting a quicker, more efficient solution. Judson's first attempts, however, were notoriously unreliable, prone to sudden, embarrassing garment failures. His clasp locker or unlocker for shoes debuted at the 1893 Chicago World's Fair, garnering little interest. The device proved difficult to operate, often sticking or pulling apart under even minimal strain, frustrating early adopters. This initial public rejection highlighted a critical engineering challenge: creating consistent, robust interlocking teeth. The market demanded a fastener that was both simple to use and absolutely dependable, a tall order. Judson continued refining his design, driven by the vision of a truly practical, modern closure system. He understood the inherent value of his invention, despite its numerous frustrating and public shortcomings. The journey of the zipper from novelty to necessity perfectly illustrates the power of iterative design. It showcases how continuous refinement and learning from failures ultimately drive revolutionary innovation. Judson's original design used hooks and eyes connected by a slider, a system inherently prone to misalignment. The individual hooks lacked the precise geometry needed for consistent, secure engagement with their corresponding eyes. Imagine trying to perfectly interlock hundreds of tiny, slightly irregular puzzle pieces using only one hand. This fundamental design flaw caused frequent separations, unraveling garments at the most awkward and public moments. But that was merely the beginning of Judson's monumental and frustrating engineering struggle, demanding radical rethinking. Later, Gideon Sundback, a Swedish-American electrical engineer, joined Judson's company, bringing fresh perspective. Sundback meticulously analyzed the flaws, recognizing the need for a completely new interlocking mechanism. He developed the hookless fastener No. 1, an improved version but still proved imperfect and often unreliable. Sundback then innovated the Placo fastener, featuring 2 rows of fabric teeth pulled together by a slider. This design improved stability, but still suffered from occasional jamming and insufficient lateral strength. Wait until you hear how he revolutionized the entire concept with a deceptively simple change. His breakthrough came with the separable fastener in 1913, featuring the modern interlocking teeth system. Sundback replaced hooks and eyes with uniform, scoop-shaped metal teeth, precisely spaced on fabric tapes. The slider now contained 2 Y-shaped channels, guiding each row of teeth into perfect, secure engagement. This ingenious design allowed the slider to force the teeth together, creating a strong, continuous closure. Each tooth featured a small hollow on one side and a protruding dimple on the other, ensuring a tight fit. It's like perfectly aligning 2 intricate combs, where each tooth fits precisely into its partner's groove. This meticulous engineering meant that once closed, the teeth resisted lateral separation much more effectively. Yet, even with Sundback's brilliant invention, the journey to universal acceptance was not immediate. Early manufacturers struggled with the precise machining required to produce these tiny, intricate components consistently. Producing millions of identical, perfectly formed teeth presented a significant industrial challenge for the era. The machines often broke down, creating imperfect teeth that would still jam or separate unexpectedly. Each production batch required rigorous testing, revealing new imperfections and demanding further adjustments. This constant cycle of production failure, and refinement became the hallmark of zipper development.
Engineers learned invaluable lessons about metal fatigue, material tolerance, and the crucial importance of manufacturing consistency.
They meticulously documented every failure, every jam, every broken tooth, meticulously cataloging the mistakes. And then came the military, unknowingly providing the ultimate proving ground for this evolving technology. The demand for reliable closures on flight suits and equipment forced rapid and remarkably robust improvements. The military's strict performance requirements accelerated the zipper's design refinement and manufacturing precision. Failures in the field directly translated to critical operational setbacks, demanding immediate, systemic solutions. This intense pressure forced engineers to confront and overcome every conceivable weakness in the design. The zipper became a symbol of wartime reliability, proving its worth under the most demanding conditions. After the wars, the zipper transitioned into civilian life, revolutionizing fashion and everyday convenience. It enabled designers to create new silhouettes, simplifying garment construction and enhancing wearability.
No longer were tedious buttons and hooks the only option for quick, secure clothing closures.
The zipper's journey exemplifies the profound power of learning from repeated, often public failures. Each jammed slider, every broken tooth, contributed valuable data for subsequent, more robust iterations. It taught engineers the absolute necessity of precise manufacturing and rigorous quality control at scale. The constant cycle of trial and error, of building and breaking, ultimately forged a superior product. This incremental improvement, driven by persistent problem-solving, transformed a flawed concept into a global standard. Without those initial, widespread failures, the zipper might have remained a niche, unreliable curiosity. Its success demonstrates that true innovation often emerges not from initial brilliance, but from relentless refinement. Embracing mistakes, analyzing their causes, and systematically implementing solutions are vital for progress. The zipper's story serves as a powerful reminder. Failure is not the end, but a stepping stone. It shows us that every setback offers a crucial opportunity for deeper understanding and significant improvement. This enduring lesson applies far beyond mere engineering, impacting nearly every facet of human endeavor. The ubiquitous zipper stands as a testament to humanity's incredible capacity for persistent, iterative problem-solving. It proves that embracing mistakes and learning from every trial and error cycle leads to undeniable, lasting success. If you found this fascinating, subscribe for more incredible stories of ingenuity and discovery, and share your thoughts below.